Hi all. Today we are solving a critical problem that we can solve with the help of the concurrency. So this video is on the bit advanced level. If you know what concurrency is and how what are the different ways we can use in the iOS to solve the concurrency problems, so only then you proceed with this video. Otherwise, I'll post a link in the chat. First, go through those videos to clear your concepts on the concurrency, then proceed with this video. So in this video, we are solving some practical problem in our day-to-day life that we can solve with the help of the concurrency. As we know, concurrency helps us to increase the speed of our application. That helps us to run multiple tasks or the multiple threads parallelly. So the concurrency or the multi-threading helps us, but we need to use it wisely. So today we are going to see one of the practical problem that we are solving in our day-to-day life, and how we can use or how we can solve with the help of the concurrency. The major problem with the concurrency is the data race or the data inconsistency, right? If multiple threads are accessing the shared common resource, so this leads to the problem of the data inconsistency, and we also called as data race. So the variable that shared resource is not properly updated by the specific thread, but the other thread is going to access it. So this leads to the problem. So today we are going to see the ticket booking system. In the ticket booking system, we are going to book the tickets and we are going to cancel some of the tickets. So we all know, like if we book the ticket more than the available tickets, this leads to the problem. And if we cancel the tickets and still our shared resource is not properly updated, again this is a big problem. So today we are going to see how we are solving this ticket booking system with the help of the concurrency, and there are several ways to solve the concurrency problem in iOS, and we are going to see the different ways and compare those ways. So let's dive into the code. Here I prepared some of the code base. So let's go through the code. So this is the ticket booking system class, and right now I have created this private variable and has a total 5 tickets available right now. And here we have created this congruent queue. So congruent queue can run task concurrently or in a parallel fashion, means like parallel is not the right word, but in a congruent way. So like, and in this booking system, in this is a function where we are booking the tickets, and here we are booking it in the asynchronous way. So this is the queue, which is the congruent queue, and we are triggering the asynchronous task. And to simulate the behavior of the API call, because in the practical world there must be some API call where we can check how many tickets are available right now and how many seats are available right now to book the tickets. So just to simulate this, I have just added a sleep for a 0.1 second, and here we are checking if the available ticket count is greater than the requested count to book the tickets. So then we are booking it, and minus the requested count from the available ticket counts, and we are just printing it like the remaining tickets available. And if the tickets are not enough, whatever the requested, we are displaying here not enough tickets available at the moment, and here we are also canceling the tickets. So in this we are also doing in the asynchronous way, and this is the congruent queue. So the booking tickets and the canceling tickets, these two are tasks are happening concurrently. And here we are making a sleep just to simulate the behavior in the same way like we did in the booking tickets, because while canceling the tickets we also need to make the API call to check from the server, like these number of tickets are available right now. So once the ticket cancellation got successful and we are adding the available tickets, and at the end, this is the another function to get the available tickets count. So we are just getting the how many tickets are available right now, and we are calling this class. See, this is our Swift UI code, and we are from the own appear method. We are calling this method booking system, and in this booking system, we created the object of this booking system, and then there is a dispatch group, and in this dispatch group, we are booking the tickets, and we are also canceling the tickets. So as we have done the dispatch group, so here we are entering the task and then leaving it. So again, while canceling it, we are entering the group and then we are leaving the group. When number of enters is equal to the number of leaves, then group notify get called, which prints their final remaining tickets available in the system. So this is the entire code base we are using to demonstrate the ticket booking system. And right now, as we can see, so we are booking the tickets and canceling the tickets are running in the asynchronous way. And again, here, this is the congruent queue. So these booking tickets and cancel tickets are run concurrently. So if we run this code and let's see the output we are getting. So here we have seen this final remaining tickets print instantly. So as this doesn't wait for this booking ticket or the cancel ticket task to complete, because they are the asynchronous task we are fetching. So, and in this you see the numbers are in the random order, like the ticket cancelled successfully and the then ticket booked. So these needs to be in a synchronous manner. Like if we are booking some of the ticket, so cancel ticket cannot get executed, and if you're canceling the ticket, so booking ticket should not get executed. Here we have seen the problem, like booking ticket and canceling ticket must be exclusive. So now how we are going to solve this problem? So let's see. We have various ways to solve this problem. The first way, we can solve it with the help of the barrier flag. So the barrier flag is available in the dispatch queue, and it provides the exclusive access to that specific block of code, and it only allows that code to execute at the time. So we need to prevent this available tickets as a, so here this available tickets is our shared resource, because this is accessed by the booking ticket as well as the cancel tickets. So first let's see how we can use the barrier flag. So this is a pretty simple approach. As we know, the dispatch queues can access the flags. So here, if we write the flag as a barrier, and this execute block is already there, so let's remove this and also add this barrier flag here. This is pretty simple way of doing this, and this solves our problem. This barrier flag provides the mutually access to this specific block of code, and if one of the code is executed, it doesn't allow another barrier to execute the code. So if the booking ticket code is executed, it doesn't allow the cancel ticket code to execute, and if cancel ticket code is executed, it doesn't allow the book ticket code to get executed. So only one task or only one method code is executed at a time. So let's run this code, and if once complete this for loop, only then this should get called and prints the remaining tickets. So let's run this code again. So here, as you see, there are one ticket booked successfully, the count remains 4, and again one ticket got cancelled, it again got to 5, and then another ticket booked successfully, it got to 4, and then 3, and then cancelled. So at the end, the all remaining tickets are 5. It is printed perfectly, because here we are doing as how many tickets are cancelled is equal to the how many tickets are booked. Like here in the for loop we are doing the 5 tickets got booked, and again we are cancelling the 5 tickets, so the count still remains the 5. So this is one of the way we can solve this problem, and the next way we can solve it with the help of the semaphores. So let's solve this problem with the help of the semaphores. So let's remove this queue from here, and create dispatch semaphore and dispatch semaphore. So we need to provide the value 1 here, because semaphores is different from the barrier in this way. Like semaphore provide access to the critical section to that number of threads we are passing through. So if we pass like 5 here, so 5 threads can access the critical section at a time. This is helpful in some of the ways, but here like we need only one thread to access the critical section, as this is the book ticket is the and the cancel ticket, these two are the critical sections, and we want only one thread must access the critical section at a time. So here uh, let's see, we need to use semaphore dot wait, and at the end of this section we need to use semaphore dot signal. So this work in the counter fashion, like if there is a wait, decrease the count by 1, and when this signal calls it increase the count by 1. So when the wait is called, if the value is negative, then it doesn't allow access to the other threads. So here the same thing we need to do here for the canceling ticket also, and then uh, we at the end we call the signal. And now if we run this code, so we will see here this should work fine. So we see the final remaining tickets again 5. The how many the number of tickets we booked is equal to the number of cancelled tickets, so again it's led to the 5. So this is correct. So this is the another way to solve this concurrency problems. And now we have another way to solve this concurrency problem with the help of the operation queues. So let's see how can we solve this with the help of the operation queue. So let's update our code, remove this. here we done our changes. So as we created the operation queue and add the maximum concurrent operation count as 1, so that we can execute those operations serially in the operation queue. So the operations are by default synchronous in nature, so we are adding to the queue to simulate our concurrent behavior. So and by adding this one, so this act as a serial queue. And here we have created this another block operation. The block operation is used to create the operations block, so that we can execute that block of code. So and then we have added this book operation in the operation queue. Similarly, we have created the cancel operation and added to the operation queue. And again, this available tickets count, we created another operation and we added this operation to the wait until finished, until the operation queue got finished, so this operation get executed at the end. So let's run this code. And as we are running this operations under the dispatch queue for making the asynchronous code, but here the operations are executed in a synchronous way, and also with the help of this we are executing in a as a serial queue. So let's run our code and see the output. So this is our code. Ignore this error. So finally we got the output, and this final remaining ticket executed at the end after executing, after completing all the operations. So this way we can handle our problem, concurrency problem, with the help of the operation queue as well. So next we are going to see how we can solve this kind of a problem with the help of the actors also. Let's update our code, change this class to actor and remove all this. Here we updated our code based on the actors. So here we have replaced the keyword class with the actor, and you see all the code related to dispatch queue and all is moved away from this. So here and also the code related to operation and all. So it's become more cleaner way to write the code. So here, so let's I guess do bit indentation also. So see here, so this all is the same, so there is nothing as such kind of a uh, either operations or the queue code. So here we have just make this class as an actor, so to make it thread safe. As we know, as we have created actors, actors are thread safe by default. They allow access only one resource, one thread at a time to access the resources. So this, and we are calling it from here, and we have used it, make it this booking system as a method as async, and we are calling all these methods with the await keyword, because while calling the book ticket we need to await. And again then, because we this is an actor method, right now whatever the resource, whatever the methods we are accessing of the actor, we need to mark it with the await keyword. And also at the end, when the group is get notified, so we are calling this here. And to call this method again, we need to create an asynchronous environment under the task keyword. So let's run this code again here. Let's see. Now, look, this is also working perfectly. The final remaining ticket call at the end, and the number of ticket we are successfully booking and again we are canceling. These two operations are running parallelly. So these are handling task, but the resource here you see the available resource under the actor is accessed exclusively. Only one thread can access the actors at a time. Either if the booking ticket is accessed, the cancel we cannot call the cancel, and if we calling the cancel we cannot access the book tickets. So this is the way we can solve our concurrency problems. These are the different ways. Hope you learn something new today, and so if you like the video, please do like and subscribe to the channel. See you in the other video. Thank you.